Hello, welcome to the second video about the electrochemistry. And in the first video we discussed about several questions and several examples. I have given some questions, then you can check your answers and check your questions with these answers and check answers, and if there is any problem, just go to the previous video and try to understand what is the point did you miss, and then come back here and then further study for these answers. And then at the second video, in this part we are going to discuss about the metal insoluble salt electrode. So there are different types of electrodes. The first part is about caramel electrode, and second part is about the silver chloride electrode. And first we discuss about the caramel electrode. There is a KCl solution for the connection for the ion exchange purpose. And then in this diagram you can see the what about the parts of the caramel electrode, and here you can see there exists KCl solution and also HgCl2 that's a solid component, and mercury, this liquid. Mercury means actually the standard natural formation, stand for natural occurring of the mercury as a liquid, so mercury, and the HgCl2 solid. So there exists equilibrium. Now this is the equation that happened at the caramel electrode. So there's the equilibrium and oxidation and reduction reaction, and you can see the equation. At any time you can use one of these reaction if there is a connection between another electrode with this one. And then next we are going to discuss about silver chloride electrode. And in this diagram you can see all the part of silver chloride electrode, and there exists silver wire, and there's a coating of silver chloride on it, and then after that there's a solution of KCl to the ion exchange process. And there's the important part of this one is there's a tip. So this tip, this consists with ceramic or quartz or something. So the reason is this is the contact point of the electrode with other solution. So this silver chloride electrode is very important thing because it is used as a reference electrode also, because previously we discussed about hydrogen electrode just used as the reference electrode and as the standard electrode, but this one also used as a reference electrode, not in A level, but when we go into the higher study in the research level, they use this silver chloride electrode as the reference electrode for some purposes. And when consider about this electrode, there exists also oxidation and reduction process. Now you can see the reaction for the equilibrium for this silver chloride electrode. Okay, in this equilibrium, there exists equilibrium in this silver chloride electrode as an oxidation or reduction reaction. Then for the understanding of these two electrodes, then we can study some previous exam question. Then using that exam question you can get good knowledge about this one. Now we are going to the question 2017 question number 10, part B, electrochemistry part. Just study the question and then you can identify what is the type of electrode, what are the point of electrode, these type of electrode using in the points. So in this question we are going to analyze what are the points and what are the oxidation reduction reaction also. Okay, let's see the question and then we go for the analysis of this question which relevant to this metal insoluble salt electrode. Now, here you can see they have given the electrode potential with respect to silver chloride electrode and calomel electrode. So you can see the calomel electrode potential is 0.27 and this one 0.22. Now according to this one, you can identify what is the oxidation and what is the reduction end. Now when consider about the most positive electrode potential, this one is the most positive one, 0.27 calomel electrode or mercury chloride electrode. So you can see this one is the highest electrode potential. So this is the reducing part, and then eventually you can identify the first one. This one is the oxidizing part. So then you can identify easily what is the oxidizing part and reducing part. Then you can write the reaction for the oxidation part and the reduction part, and then you can go for the overall reaction, and then you can go for the what is the final electromotive force of the cell, and likewise. So now let's see what is the oxidation reaction and the reduction reaction. So reduction part is the calomel electrode part. So then we can write the reduction reaction like this. So this is the reduction reaction. Then at the same time you can write the oxidation reaction. Now we can write the oxidation reaction. Let's write it. So this is the oxidation reaction. Now using this one, then you can write the overall reaction. As the last part of the electrode, the last part of the electrode type is we called redox electrode. So in this diagram you can see there's an electrode. This consists with Fe2 plus and Fe3 plus. So Fe2 plus and Fe3 plus, this containing in the solution. So in this electrode you can see there's a only oxidation process and reduction process in the solution, and the electrons are just moving due to this oxidation and reduction of the solution. So you can see the diagram and easily you can understand what is the equilibrium exists here. Then this is just simple, the simple one. So now you can identify what about the oxidation reduction reaction. There's a connection for the external connection for this electrode, and it consists with platinum or palladium just coated with the net material. So this is, there's nothing special, just only this one for the reaction and equilibrium. So if there's any connection for this type of electrode, then you can identify in the questions at the exam questions. Okay, now we discuss about the what is the spontaneity of electrochemical cell. Spontaneity means, so in the enthalpy lesson we just know about the what is the spontaneous process. Spontaneous means, so same meaning here and here. The spontaneity means when considered about electrochemical cells, the EMF value should be greater than 0 for the spontaneous reaction. Or spontaneous here means if EMF value greater than 0. If EMF value greater than 0, then it is, we call it is a spontaneous reaction or cell reaction. Cell reaction means, so energy should be released to the outside for in electrochemical cell. If not, if EMF value is negative value, so then we can't give, or we can't refer it as a electrochemical cell. Cell means, so there is no energy releasing. Just minus value means, negative value means just energy absorbing. So it is not a electrochemical cell furthermore. So therefore EMF value should, if EMF value is greater than 0, then we call it an spontaneous reaction just for the electrochemical cell. And then we just then we discuss about what is the deposition and dissolving of some electrode. Now, think about this electrode system. Now, let's think about A is one electrode, B is another electrode. Then we consider about in exam question they ask about which one is the deposition electrode or which one is the dissolving electrode. So, according to this one, we can identify which one is the dissolving or which one is the deposition electron. So, as example, we just take A as zinc and copper. A is the zinc, B is the copper. Then we can identify the deposition part and also dissolving part according to the electrochemical series. Now we go to the electrochemical series. According to electrochemical series, the zinc is top and the copper is in the down area. So therefore, when we go down the electrochemical series, those components are more likely for the reduction process. Therefore, here the most probable reaction is copper 2 plus. So, according to electrochemical series or electrode potential, we can identify which one is the oxidizing part and reducing part. So, here copper is more favorable for reducing. Therefore, copper is the deposition part and zinc is the oxidizing part as more favorable for oxidation according to the electrochemical series with respect to zinc and copper. So, if there is any question type, if they ask about find the deposition part or dissolving part, then you can identify according to the electrode potential. Then it is very easy for your understanding. Now we are going to discuss about what are the type of electrochemical cells. So when consider about electrochemical cells, so basically there is two types of electrochemical cell. We call primary electrochemical cells and secondary electrochemical cell. Okay, when we consider about primary types of electrochemical cell, so just normal Daniell cell and Leclanche cell just categorized under this primary electrochemical cell, and according to the secondary electrochemical cell, we can categorize normally we called car batteries. So car batteries are just categorized under secondary electrochemical cell. So now you can see the diagram of normal Leclanche cell and the Daniell cell and also normal car battery. So when consider about this type of electrochemical cells, so secondary, the main difference is secondary electrochemical cells we can use by normally we call rechargeable batteries. So we can reverse the electrochemical reaction and we can just charge the electrochemical cell by applying current. So this is only applicable for the secondary secondary type of electrochemical cells. So primary type of electrochemical cells we can't go for the rechargeable process. Okay, so according to this type of electrochemical cells, now you can identify. So these are normal usage of the electrochemical cell, and just see this diagram, and then you can identify what are the chemical reaction and what are the oxidation part, reduction part. Then just by using this one, you can just identify what are the parts. So now we are going to discuss about what are the factors affecting on electromotive force. Now you can see these are the factors just affecting on electromotive force. So according to this one, you can identify just there's a huge effect from the concentration of the electrolyte. When consider about electrolyte, if you use 0.1 mole for KZA solution or Then if you use 1 mole for cubic decimeter KCl solution, then there's a different type of electrolyte solutions according to concentration. Then it will directly affect on the electromotive force if you use a different type of concentration solution. And also there's another factor we call temperature. Temperature also problem for the electromotive force. Now you can remember the problem just found on the Samsung phone series. There's a problem with the batteries, so that's a factor is the temperature. So those type of example just try to keep it in mind. So for the electrochemical cell, this is a simple example. So when consider about temperature, and also there's an effect from the pressure, and also effect from the nature of the electrolyte. So if you use solid electrolyte or if you use liquid electrolyte, there's a different type of electromotive force. It will just directly affect on the electromotive force, and slightly different of the electromotive force will obtain with the use of this factor, so changing of this factor. So when you write the question answers, then just consider about these factors and manage your answer with these factors.